How in the heck do nutrients become toxic in the environment? Well, there's a number of ways that this can occur, and I only list several of those on this slide. But number one, fertilizer overapplication by choice for some reason or by mistake. Maybe you were filling the hopper on your fertilizer spreader and you spilt fertilizer all over the place and you ignored it. And it killed everything that was underneath where the fertilizer was located on a parcel of land. Flooding conditions certainly can cause problems, right? So we learned about iron 3 and iron 2 way back when, earlier in the semester, and that iron 3 is taken up by plants, and so is iron 2. And iron 2 is typically found or oftentimes found under reduced conditions like saturated conditions, and iron 3 is under unsaturated or oxygenated conditions. And most of our plants grow under oxygenated conditions, and iron 3 is several orders of magnitude less available than iron 2 in the environment. Or manganese, and we have issues with manganese that follow the same sort of rules. So iron 2 is more available than iron 3, and iron 2, unfortunately, is available under typically saturated conditions. So we could have a toxicity of iron simply because of flooded conditions. Certainly, acid mine drainage can lead to toxicities where the pH of acid mine drainage affects soils and can reduce the pH to below 5.5 or below 5, or sometimes even below 3. Air pollution and deposition, for example, sulfur that's emitted from a stack from some industry that forms sulfuric acid in the atmosphere and falls back to the ground as acid rain. Galvanized metal dumping, for example, galvanized metal typically contains quite a bit of zinc. And so these areas that have galvanized metal that are simply dumped in a location can have zinc toxicities. And certainly too much salt, for example, excess chloride from potassium chloride, for example, may play a role. You know, potassium is a macronutrient, but chloride is a micronutrient. So it's needed in less quantities. So if you have a great need for potassium, you may overapply chloride and end up with a problem. So targeting the first point on the previous slide, where somebody overapplied fertilizer, this picture illustrates fertilizer overapplication from right to left. And so what you see is fertilizer injury due to too much fertilizer placed too close to either the root system or the seed itself. So what do you see from right to left? Of course, you see a stunted plant above ground, but you also see a stunted plant below ground. And what has occurred by simply placing too much fertilizer with the seed, and we've talked about this throughout the semester, that the seed or the seed is actually killed, or if it's placed too close to the seed or in close proximity to the seed, it can kill the apical meristem of the root. And if the apical meristem, or the primary portion of the root where the root is emerging or growing, is killed, the plant will suffer. And if the plant can't push out secondary roots to overcome that toxicity, you see what you see in this picture from right to left. So what I want to do in the subsequent videos for this unit is to explore some of the signs of toxicity to plants simply due to excessive soil nutrients and what you could potentially do to offset those toxicity symptoms. And again, I am not going to share with you every single means by which we can offset these toxicity symptoms because they are plentiful. So I'm going to share with you some of my experiences and thoughts over the next several videos. And they pertain directly to what you had seen on the previous slide and what you see here where root systems are stunted and above ground plant growth looks just a little bit off, or in the case of micronutrient toxicities like you see in this picture here on geranium, what happens to the plant in the presence of excess copper or iron, manganese, or zinc. And I think I'll steer clear of molybdenum and boron because we really didn't touch on these over this class. But you can see the visual symptoms: shortened above ground plants, probably stunted, certainly chlorotic in some cases, and maybe showing signs of actually a different deficiency symptom. So we will begin exploring this next.